All right, so the next thing that we're going to do is figure out how to adjust the flow rate to get this IV back on track so it would finish in the 6-hour time that was scheduled. To do this, I like to have a little diagram to help me see literally what's going on. I know you guys will like my drawing here. So we have the IV bag, and we have 1,500 milliliters in that IV, and we know after, what was this, 1,500 to 1,300, 2 hours time, 600 milliliters actually went into the patient. And so we can subtract and say the 1,500 milliliters minus 600 milliliters, we would have 900 milliliters remaining in the bag. I didn't quite make my bag big enough there, but hopefully you see. So we have 900 milliliters still to be infused in the patient, and we know the original infusion was scheduled for 6 hours. On here, and so we can look and then see that, oh, we've got 4 hours left here for this 900 milliliters to be infused. So that is the volume, sorry about that, that is the volume and the time that still needs to be infused into the patient. So we'll do like a REM, volume remaining over time remaining, because flow rates are volume over time. And let's see, we have 900 milliliters to be infused in 4 hours. So to estimate this, we'll do 4 goes into 9 2 times, so this should be around 200. And then if we punch this in the calculator, I think we'll come up with 225 milliliters per hour. Note the IV was scheduled to run at 250 milliliters per hour. Because it was running ahead of schedule, we're going to be slowing it down to 225 milliliters per hour. And we can write that flow rate. Since it's a gravity feed, we really want to know drops per minute. So let's take that 225 milliliters for every 1 hour, and we want to get that to drops per minute. So let's trade that 1 hour in for 60 minutes. And to find out the number of drops in 225 milliliters, let's multiply by the drop factor of 15 drops per milliliter. So note we're multiplying. This is the unit analysis where the units will cancel diagonally, and we're left with drops on the top, minutes on the bottom. That's what we want, drops per minute. And we can multiply across to get the number. So we'll go 225 times 15, and then we'll divide by 60. And this will give us our, oh, I'm running out of room, but this will be drops per minute. To estimate this, I can say 15 goes into 60 4 times. I'll say 4 goes into 22 5 times, so this should be about 50 drops per minute. And I think if we calculate this, will come out to be 56.25 drops per minute. And we'll round that and say 56 drops per minute, rounding to the nearest whole number. Now the other thing that you'll have on the homework is a percent variation. And this percent variation will be the change or the error in the IV, how far it's off compared against the scheduled amount. So we are off, 56 drops per minute, and it was scheduled to be at 63. And we'll compare that against the 63 drops per minute. So if we subtract these, we actually get a negative number. The negative just means that we're running behind schedule. And if we divide the 7 divided by 63 on a calculator, think we come up with 0.11, and if we change that to a percentage, actually a negative, and the negative changing to a percentage would be 11%. The negative just means that we're running behind schedule, or we're going to be, lowering the flow rate from the scheduled. And we'll say the 11% is less than what the book uses as a rule of thumb, not to exceed 25% variation. So we'll say since the variation is 11%, it's less than the rule of thumb, then we can safely adjust the IV to the 56 drops per minute that we calculated. So I hope this has been helpful, and we will be seeing you later. All right, bye-bye.